Hello everyone, I'm Matashimi and I'm here with another tutorial about machine learning and deep learning. I hope you liked the other courses and made the most out of them. First, I want to talk to you about machine learning and deep learning, and then let's use it together in practical projects. Machine learning is a type of artificial intelligence that allows software applications to become more accurate at predicting outcomes without being explicitly programmed to do so. Machine learning algorithms use historical data as input to predict no output values. Recommendation engines are a common use case for machine learning. Other popular uses include fraud detection, spam filtering, malware threat detection, business process automation, and predictive maintenance. Machine learning is important because it gives enterprises a view of trends in customer behavior and business operational patterns, as well as supported the development of new products. Many of today's leading companies, such as Facebook, Google, and Uber, make machine learning a central part of their operations. Machine learning has become a significant competitive differentiator for many companies. Classical machine learning is often categorized by how an algorithm learns to become more accurate in its predictions. There are four basic approaches: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. The type of algorithm data scientists choose to use depends on what type of data they want to predict. This type of machine learning data scientists apply algorithms with labeled training data and define the variables they want the algorithm to assess for correlations. Both the input and the output of the algorithm is specified. This type of machine learning involves algorithms that train on unlabeled data. The algorithm scans through the dataset looking for any meaningful connection. The data that algorithm train on, as well as the predictions or recommendations they output, are predetermined. This approach to machine learning involves a mix of the two preceding types. Data scientists may feed an algorithm mostly labeled training data, but the model is free to explore the data on its own and develop its own understanding of the dataset. Data scientists typically use reinforcement learning to teach a machine to complete a multi-step process for which there are clearly defined rules. Data scientists program an algorithm to complete a task and give it positive or negative cues as it works out how to complete the task. But for the most part, the algorithm decides on its own what steps to take along the way. Supervised machine learning requires the data scientist to train the algorithm with both labeled inputs and desired outputs. Supervised learning algorithms are good for the following tasks: binary classification, divided data in two categories, multi-class classification, choosing between more than two types of answers, regression modeling, predicting continuous values, and assembling, combining the predictions of multiple machine learning models to produce an accurate prediction. Unsupervised machine learning algorithms do not require data to be labeled. They sift through unlabeled data to look for patterns that can be used to group data points into subsets. Most types of deep learning, including neural networks, are unsupervised algorithms. Unsupervised learning algorithms are good for the following tasks: clustering, splitting the dataset into groups based on similarity; anomaly detection, identifying unusual data points in a dataset; association mining, identifying sets of items in a dataset that frequently occur together; and dimensionality reduction, reducing the number of variables in a dataset. Semi-supervised learning works by data scientists, feeding small amount of labeled training data to an algorithm. From this, the algorithm learns the dimensions of the dataset, which it can then apply to new unlabeled data. The performance of algorithms typically improves when they train on labeled datasets. But labeling data can be time-consuming and expensive. Semi-supervised learning strikes a middle ground between the performance of supervised learning and the efficiency of unsupervised learning. Some areas where semi-supervised learning is used include machine translation, teaching algorithms to translate language based on less than a full dictionary of words; fraud detection, identifying cases of fraud when you only have a few positive examples; labeling data, algorithms trained on small datasets can learn to apply data label to large sets automatically. Reinforcement learning works by programming an algorithm with a distinct goal and a pre-described set of rules for accomplishing the goal. Data scientists also program the algorithm to seek positive rewards, which it receives when it performs an action that is beneficial toward the ultimate goal, and avoid punishments, which it receives when it performs an action that gets it further away from its ultimate goal. Reinforcement learning is often used in areas such as robotics. Robots can learn to perform tasks the physical world using this technique. Video gameplay. Reinforcement learning has been used to teach bots to play a number of video games. And reinforcement management. Given finite resources and a defined goal, reinforcement learning can help enterprises plan out how to allocate resources. Today, machine learning is used in a wide range of applications. Perhaps one of the most well-known examples of machine learning in action is the recommendation engine that powers Facebook's news feed. Facebook uses machine learning to personalize how each member's feed is delivered. If a member frequently stops to read a particular group's posts, the recommendation engine will start to show more of that group's activity earlier in a feed. Behind the scenes, the engine is attempting to reinforce known patterns in a member's online behavior. Should the member change patterns and fail to read posts from that group in the coming weeks, the newsfeed will adjust accordingly. In addition to recommendation engines, other uses for machine learning include the following: customer relationship management. CRM software can be machine learning models to analyze email and prompt sales team members to respond to the most important message first. More advanced systems can even recommend potentially effective responses. Business intelligence. BI and analytics vendors use machine learning in their software to identify potentially important data points, patterns of data points, and anomalies. Human resource information systems, HRIS systems, can use machine learning models to filter through applications and identify the best candidates for an open position. Self-driving cars. Machine learning algorithms can even make it possible for a semi-autonomous car to recognize a partially visible object and alert the drive. And virtual assistants. Smart assistants typically combine supervised and unsupervised machine learning models to interpret natural speech and supply context. Machine learning has seen use cases ranging from predicting customer behavior to forming the operating system for self-driving cars. When it comes to advantages, machine learning can help enterprises understand their customers at a deeper level. By collecting customer data and correlating it with behaviors over time, machine learning algorithms can learn associations and help teams tailor product development and marketing initiatives to customer demand. Some companies use machine learning as a primary driver in their business models. Uber, for example, uses algorithms to match drivers with riders. Google uses machine learning to surface the right advertisements in search. But machine learning comes with disadvantages. First and foremost, it can be expensive. Machine learning projects are typically driven by data scientists who command high salaries. These projects also require software infrastructure that can be expensive. There is also the problem of machine learning bias. Algorithms trained on datasets that exclude certain populations or contain errors can lead to inaccurate models of the world that at best fail and at worst are discriminatory. When an enterprise bases core business processes on biased models, it can run into regulatory and reputational harm. The process of choosing the right machine learning model to solve a problem can be time-consuming if not approached strategically. Step 1. Align the problem with potential data inputs that should be considered for the solution. This step requires help from data scientists and experts who have a deep understanding of the problem. Step 2. Collect data, format it, and label the data if necessary. This step is typically led by data scientists with help from data wrangles. Step 3. Choose which algorithm to use and set to see how well they perform. This step is usually carried out by data scientists. And step 4. Continue to fine-tune outputs until they reach an acceptable level of accuracy. This step is usually carried out by data scientists with feedback from experts who have a deep understanding of the problem. Explaining how a specific machine learning model works can be challenging when the model is complex. There are some vertical industries where data scientists have to use simple machine learning models because it's important for the business to explain how a decision was made. This is especially true in industries with heavy compliance burdens such as banking and insurance. Complex models can produce accurate predictions, but explaining to a layperson how an output was determined can be difficult. While machine learning algorithms have been around for decades, they've attained new popularity as artificial intelligence has grown in prominence. Deep learning models, in particular, power today's most advanced AI applications. Machine learning platforms are among enterprise technology's most competitive realms, with most major vendors, including Amazon, Google, Microsoft, IBM, and others, racing to sign customers up for platform services that cover the spectrum of machine learning activities, including data collection, data preparation, data classification, model building, and application development. As machine learning continues to increase in importance to business operations, and artificial intelligence becomes more particular in enterprises settings, the machine learning platform wars will only intensify. Continued research into deep learning and artificial intelligence is increasingly focused on developing more general applications. Today's AI models requires intensive training in order to produce an algorithm that is highly optimized to perform one task. But some researchers are exploring ways to make models more flexible and are seeking technologies that allow a machine to apply context learned from one task to future different tasks. Tipping waiters for serving food depends on many factors like the type of restaurant, how many people you are with, how much amount you pay as your bill, and etc. Waiter tips analysis is one of the popular data science case studies where we need to predict the tips given to a waiter for serving the food in a restaurant. So if you want to learn how to solve this case study, this tutorial is for you. In this tutorial, I will take you through the task of a waiter tips prediction with machine learning using Python. The food server of the restaurant recorded data about the tips given to the waiters for serving the food. The data recorded by the food server is as follows. 1. Total bill in dollars including taxes. 2. Tip given to waiters in dollars. 3. Sex, gender of the person paying the bill. 4. Smoker, whether the person smoked or not. 5. Day of the week. 6. Time, lunch or dinner. And 7. Size, number of people in a table. So this is the data recorded by the restaurant. Based on this data, our task is to find the factors affecting waiter tips and train a machine learning model to predict the waiter's tipping. Now let's start the task of waiter tips analysis and prediction by importing the necessary Python libraries and the dataset. This is our dataset, and let's move forward by analyzing all the factors affecting waiter tips. Let's have a look at the tips given to the waiters according to 1. The total bill paid, 2. Number of people at a table, and 3. The day of the week. Now let's have a look at the tips given to the waiters according to 1. The total bill paid, 2. the number of people at the table, and 3. the gender of the person paying the bill. Now let's have a look at the tips given the waiters according to 1. the total bill paid, 2. the number of people at the table, and 3. the time of the meal. Now let's see the tips given to the waiters according to days to find out which day the most tips are given to the waiters. According to the visualization, on Saturdays, most tips are given to the waiters. Now let's look at the number of tips given to the waiters by gender of the person paying the bill to see who tips waiters the most. According to the visualization above, most tips are given by men. Now let's see if a smoker tips more or a non-smoker. According to the visualization, non-smoker tips waiters more than smokers. Now let's see if most tips are given during lunch or dinner. According to the visualization, a waiter is tipped more during dinner. So this is how we can analyze all the factors affecting waiter tips. Now in the section below, I will take you through how to train a machine learning model for the task of waiter tips prediction. Before training a waiter tips prediction model, I will do some transformation by transforming the categorical values into numerical values. Now we'll split the data into training and test sets. Now blue is how we can train a machine learning model for the task of weather tips prediction using Python. So let's test the performance of this model by giving inputs to this model according to the features that we have used to train this model. So this is how you can predict weather tips with machine learning using Python. Predicting the future sales of a product helps a business manage the manufacturing and advertising cost of the product. There are many more benefits of predicting the future sales of a product. So if you want to learn to predict the future sales of a product with machine learning, this tutorial is for you. In this tutorial, I will take you through the task of future sales prediction with machine learning using Python. The dataset given here contains the data about the sales of the product. The dataset is about the advertising cost incurred by the business on various advertising platforms. This is the description of all the columns in the dataset. 1. TV. Advertising costs spent in dollars for advertising on TV. 2. Radio. Advertising costs spent in dollars for advertising on radio. 3. Newspaper. Advertising costs spent in dollars for advertising on newspaper. And 4. Sales. Number of units sold. So in this dataset, the sales of the product depend on the advertisement cost of the product. I hope you now understood everything about this dataset. Now in the section below, I will take you through the task of future sales prediction with machine learning using Python. Let's start the task of future sales prediction with machine learning by importing the necessary Python libraries and datasets. Let's have a look at whether this dataset contains any null values or not. So this dataset doesn't have any null values. Now let's visualize the relationship between the amount spent on advertising on TV and units sold. Now let's visualize the relationship between the amount spent on advertising on newspaper and units sold. Now let's visualize the relationship between the amount spent on advertising on radio and units sold. Out of all the amount spent on advertising on various platforms, I can see that the amount spent on advertising the product on TV results in more sales of the product. Now let's have a look at the correlation of all the columns with the sales column. Now in this section, I will train a machine learning model to predict the future sales of a product. But before I train the model, let's split the data into training and test sets. Now let's train the model to predict future sales. Now let's input values into the model according to the features we have used to train it and predict how many units of the product can be sold based on the amount spent on its advertising on various platforms. So this is how we can train a machine learning model to predict the future sales of a product. Predicting the future sales of a product helps a business manage the manufacturing and advertising costs of the product. I hope you like this tutorial. You must have heard or invested in any cryptocurrency once in your life. It is a digital medium of exchange that is encrypted and decentralized. Many people use cryptocurrencies as a form of investing because it gives great returns even a short period. Bitcoin, Ethereum, and a Binance coin are among of popular cryptocurrencies today. If you want to know how to predict the future prices of any cryptocurrency with machine learning, this tutorial is for you. In this tutorial, I will walk you through the task of cryptocurrency price prediction with machine learning using Python. Predicting the price of cryptocurrencies is one of the popular case studies in the data science community. The prices of stocks and cryptocurrencies don't just depend on the number of people who buy or sell them. Today, the change in the prices of these investments also depends on the change in the financial policies of the governments regarding any cryptocurrency. The feelings of people towards a particular cryptocurrency or personality who directly or indirectly endorse a cryptocurrency also result in a huge buying and selling of a particular cryptocurrency, resulting in a change in prices. In short, buying and selling result in a change in a price of any cryptocurrency, but buying and selling trends depend on many factors. Using machine learning for cryptocurrency price prediction can only work in situations where prices change due to historical prices that people see before buying and selling the cryptocurrency. So in this section, I will take you through how you can predict the Bitcoin prices for the next 3 days. We'll start the task of a cryptocurrency price prediction by importing the necessary Python libraries and the dataset we need. For this task, we will collect the latest Bitcoin prices data from Yo Finance using the Y Finance API. This will help you collect the latest data each time you run this code. In the above code, I have collected the latest data of Bitcoin prices for the past 730 days, and then I have prepared it for any data science task. Now let's have a look at the shape of this dataset to see if you are working with 730 rows or not. First row contains the names of each column. Now let's visualize the change in Bitcoin prices till today by using a candlestick chart. The kilos column in the dataset contains the values we need to predict. So let's have a look at the correlation of all the columns in the data considering the kilos column. Predicting the future prices of cryptocurrency is based on the problem of time series analysis. The AutoTS library in Python is one of the best libraries for time series analysis. So here I will be using the AutoTS library to predict the Bitcoin prices for next 30 days. So this is how you can use machine learning to predict the price of any cryptocurrency by using the Python programming language. I hope you like this tutorial on cryptocurrency price prediction with machine learning using Python. LSTM stands for Long Short-Term Memory Networks. This is a type of recurrent neural network that is commonly used for regression and time series forecasting in machine learning. It can memorize data for long periods, which differentiates LSTM neural networks from other neural networks. If you want to learn how to predict stock prices with LSTM, this tutorial is for you. In this tutorial, I will walk you through the task of stock price prediction with LSTM using Python. Using LSTM is one of the best machine learning approaches for time series forecasting. LSTMs are recurrent neural networks designed to remember data for a longer period. So whenever you are working on a problem where your neural network fails to memorize data, you can use LSTM neural network. Now in this section, we will take you through the task of stock price prediction with LSTM using the Python programming language. I will start this task by importing all the necessary Python libraries and collecting the latest stock price data of Apple. The candlestick chart gives a clear picture of the increase and decrease in stock prices. And so let's visualize a candlestick chart of data before moving further. Now let's have a look at the correlation of all the columns with the close column as it is the target column. Now we'll start with training an LSTM model for predicting stock prices. I will first split the data into training and test sets. Now we'll prepare a neural network architecture for LSTM. Now here is how we can train our neural network model for stock price prediction. Now let's test this model by giving two values according to the features that we have used to train this model and predicting the final results. So this is how we can use LSTM neural network architecture for the task of stock price prediction. I hope you like this tutorial on predicting stock prices with LSTM using Python. In machine learning, classification means categorizing the non-classes. For example, categorizing the most profitable and non-interested customers from a dataset for advertising a particular product. You must have trained a classification model with a machine learning algorithm before. But if you want to learn about training a classification model with neural networks, this tutorial is for you. In this tutorial, we will take you through the task of classification with neural networks using Python. Classification is the task of categorizing the non-classes based on their features. In most classification problems, machine learning algorithms will do the job, but while classifying a large dataset of images, you will need to use a neural network. If you have never trained a neural network and want to learn how neural networks work, you can learn everything about a neural network in this tutorial. Now, let's come back to classification with neural networks. In this section, I will take you through the task of image classification with neural network using Python. Here, I will be using the famous MNIST fashion dataset, which contains 70,000 clothing fashion images. Here, our task is to train an image classification model with neural networks. I will start this task by importing the necessary Python libraries and the dataset. Before moving forward, let's have a quick look at one of the samples of the image from the dataset. Now let's have a look at the shape of both the training and test data. Now we'll build a neural network architecture with two hidden layers. Before training our model, I will split the training data into training and the validation sets. Now here's how we can train a neural network for the task of image classification. Now let's have a look at the predictions. Here is how we can look at the predicted classes. So this is how you can train a classification model with neural networks using Python. I hope you like this tutorial on classification with neural network using Python. A machine learning algorithm is used to find relationships between features and labels. Features are the independent variables that we feed into the algorithm to train a machine learning model, and labels are the depends variables that we aim to predict using the machine learning algorithm. If you have trained a machine learning model before but have never visualized a machine learning algorithm, then this tutorial is for you. In this tutorial, we will take you through how to visualize a machine learning algorithm using Python. Visualizing a machine learning algorithm means visualizing a trending of the predicted values by the machine learning algorithm. What happens in that when we train a machine learning model using an algorithm, we feed the data into the algorithm. The algorithm finds the relationship between features and labels. So we visualize a machine learning algorithm. It shows the trend line of the values of the predicted labels according to the features. Now, I will show you how to train a simple machine learning algorithm and visualize it using Python. Here I will first train a linear regression model to predict the sales of a product based on the amount spent on its TV advertising, and then I will visualize the predictions of the linear regression algorithm by using the plotly library in Python. In this figure, the red line is a trending that shows the predictions made by the linear regression algorithm, which is nothing but the relationship between the amount spent on advertising on television and the sales of the product. And this is how you can have a look at all the predicted values by the machine learning algorithm. I hope you liked this tutorial on how to visualize a machine learning using Python. Instagram is one of the most popular social media applications today. People using Instagram professionally are using it for promoting their business, building a portfolio, blogging, and creating various kinds of content. As Instagram is a popular application used by millions of people with different needs, Instagram keeps changing to make itself better for the content creators and the users. But as this keeps changing, it affects the reach of our posts that affects us in the long run. So if a content creator wants to do well on Instagram in the long run, they have to look at the data of their Instagram reach. That is where the use of data science in social media comes in. If you want to learn how to use our Instagram data for the task of Instagram reach analysis, this tutorial is for you. In this tutorial, we will take you through an Instagram reach analysis using Python, which will help content creators to understand how to adapt to the change in Instagram in the long run. I have been reaching Instagram reach for a long time now. Every time is post on my Instagram account, I collect data on how well the posts reach after a week. That helps in understanding how Instagram's algorithm is working. If you want to analyze the reach of your Instagram account, you have to collect your data manually, as there are some APIs, but they don't work well. So it's better to collect your Instagram data manually. If you are a data science student and want to learn Instagram reach analysis using Python, you can use the data I have collected from my Instagram account. Now in this section, I will take you through the task of Instagram reach analysis and prediction with machine learning using Python. Now let's start the task of analyzing the reach of my Instagram account by importing the necessary Python libraries and the datasets. Before starting everything, let's have a look at whether this dataset contains any null values or not. So it has a null value in every column. Let's drop all these null values and move further. Let's have a look at the insides of the columns to understand the data type of all the columns. Now let's start with analyzing and reach of my Instagram posts. I will first have a look at the distribution of impressions I have received from home. The impressions I get from the home section on Instagram shows how much many posts reach my followers. Looking at the impressions from home, I can say it's hard to reach all my followers daily. Now let's have a look at the distribution of the impressions I received from hashtags. Hashtags are tools we use to categorize our posts on Instagram so that we can reach more people based on the kind of content we are creating. Look at hashtag impressions shows that not all posts can be reached using hashtags, but many new users can be reached from hashtags. Now let's have a look at the distribution of impressions I have received from the Explore section of Instagram. The Explore section of Instagram is the recommendation system of Instagram. It recommends posts to the users based on their preferences and interests. By looking at the impressions I have received from the Explore section, I can say that Instagram does not recommend our post much to the users. Some posts have received a good reach from the Explore section, but it's still very low compared to the reach I receive from hashtags. Now let's analyze the content of my Instagram posts. The dataset has two columns, namely caption and hashtags, which will help us understand the kind of content I post on Instagram. Let's create a word cloud of the caption column to look at the most used words in the caption of my Instagram posts. Now let's create a word cloud of the hashtags column to look at the most used hashtags in my Instagram posts. Now let's analyze relationships to find the most important factors of our Instagram reach. It will also help us in understanding how the Instagram algorithm works. Let's have a look at the relationship between the number of likes and the number of impressions of my Instagram posts. There is a linear relationship between the number of likes and the reach I got on Instagram. Now let's see the relationship between the number of columns and the number of impressions my Instagram posts. It looks like a number of comments we get on a post doesn't affect its reach. Now let's have a look at the relationship between the number of shares and the number of impressions. A more number of shares will result in a higher reach, but shares don't affect the reach of a post as much as likes do. Now let's have a look at the relationship between the number of saves and the number of impressions. There is a linear relationship between the number of times my post is saved and the reach of my Instagram post. Now let's have a look at the correlation of all the columns with the impressions column. So we can say that more likes and saves will help you get more reach on Instagram. The higher number of shares will also help you get more reach, but a low number of shares will not affect your reach either. In Instagram, conversation rate means how many followers you are getting from the number of profile visits from a post. The formula that you can use to calculate conversation rate is followers divided profile visits multiple 100. Now let's have a look at the conversation rate of my Instagram account. Let's have a look at the relationship between the total profile visits and the number of followers gained from the profile visits. The relationship between profile visits and followers gained is also linear. Now in this section, I will train a machine learning model to predict the reach of an Instagram post. Let's split the data into training and test sets before training the model. Now here is how we can train a machine learning model to predict the reach of an Instagram post using Python. Now let's predict the reach of an Instagram post by giving inputs to the machine learning model. So this is how you can analyze and predict the reach of Instagram posts with machine learning using Python. Even content creator wants to do well on Instagram in the long run, they have a look at the data of their Instagram reach. That is where the use of data science in social media comes in. I hope you liked this tutorial on a task of Instagram reach analysis using Python. The price of a product is the most important attribute of marketing that product. One of those products where price matters a lot is a smartphone, because it comes with a lot of features, so that the company thinks a lot about how to price this mobile, which can satisfy the features and also cover the marketing and manufacturing costs of the mobile. In this tutorial, we will walk you through the task of mobile price classification with machine learning using Python. Mobile phones are the best-selling electronic devices, as people keep updating their cell phones whenever they find new features in a new device. Thousands of mobiles are sold daily. In such a situation, it is a very difficult task for someone who is planning to set up their own mobile phone business to decide what the price of the mobile should be. In this section, I will introduce you to a machine learning project on a mobile price classification model, where I will train a model to classify the price range of mobiles using Python. So, since our task is to classify the price range of mobile phones and not to predict the actual prices, so here I'm going to train a classification model to classify the price range of mobile phones as 0 low cost, 1 medium cost, 2 high cost, and 4 very high cost. I will start the task of mobile price classification with machine learning by importing the necessary Python libraries and the datasets. So the dataset contains 21 columns, and likely this dataset has no missing values, so we can just start by training the model. But before that, let's take a look at the correlation between the features in a dataset. This dataset has no categorical features, so we can just use this data without any transformation because all the features of the dataset are numeric. But to train a model, it's very important to standardize or normalize the data and break it up into training and testing sets. So let's standardize the dataset and divide the data into 80% training and 20% testing. Now let's train the mobile price classification model using Python. As this is a problem of classification, I will be using the logistic regression algorithm provided by Scikit-learn. Now let's have a look at the accuracy of the model. So the model gives an accuracy of about 95.5%, which is great. Now let's have a look at the predictions made by the model. This output shows the price range classified by the model. Let's have a look at the number of mobile phones classified for each price range. I hope you like this tutorial on mobile price classification with machine learning. Gold has always held a prominent place in the country's economy and among the people. In this tutorial, I will introduce you to a machine learning tutorial on gold price prediction with Python. Gold prices have historically skyrocketed, peaking at 2000 in 2023. These swings that gold has faced can be attributed to several events that occurred during the period. Stock prices are strongly correlated with public information and world events, and gold is no exception. Unlike other financial assets, precious metals behave positively in times of crisis. Indeed, in the face of events such as epidemics, wars, and economic disruption, most assets experience a decline in their value. However, in search of cover, investors are tuning their attention to gold. As a result, the demand for yellow metal increases, resulting in a rise in a market valuation. Gold tends to be viewed as a strategic and tactical investment asset when considering portfolio diversification. However, the economic and financial aspects are not the only factors that can affect gold prices. Geopolitical factors may also influence the valuation of the yellow metals market. Indeed, show that faced with geopolitical risks, gold acts as a safe haven. In fact, it has an affirmative reaction in times of threats resulting from geopolitical and international tensions. By analyzing financial, geopolitical, and global data on natural disasters, it's possible to predict future fluctuations in the price of gold, which will allow investors to improve the management of their portfolio in the face of unexpected movements of the market. In this section, I will take you through a machine learning tutorial on gold price prediction with Python. I will start the task of gold price prediction by importing the necessary Python libraries and the dataset. Now let's do some data preparation to feed the data properly in our machine learning model. Now, as we have prepared the data to feed in a machine learning model for the task of gold price prediction, the next step is to choose a machine learning algorithm. For this task, I will use the linear regression algorithm. Now let's plot the results of gold price prediction that we got from the linear regression algorithm. I hope you like this tutorial on the machine learning on gold price prediction with Python. Language translation is a method of converting the source sentence from one natural language to another natural language using computerized systems, and human assistance is not required. In this tutorial, I will introduce you to a machine learning project on language translation with Python programming language. Deep learning is a recently used approach for language translation. Unlike traditional machine translation, neural machine translation is a better choice for more accurate translation and also offers better performance. DNN can be used to improve traditional systems to make them more efficient. Different deep learning techniques and libraries are needed to develop a better language translation system. RNN, LSTM, and etc. are used to train the system, which will convert the sentence from the source language to the target language. Adopting the appropriate networks and deep learning strategies is a good choice, as it has turned the system to maximize the accuracy of the translation system relative to others. In this section, I will take through a machine learning project on language translation with Python. Here, I will be creating a machine learning model to translate English to Hindi. Let's get started with this task by importing the necessary Python libraries and the datasets. For simplicity, I will lowercase all the characters in a dataset. Now I will remove all the quotes from the data. Now I will remove all the special characters in the data. Now I will remove all the numbers and extra spaces from the data. Now, as we have cleared the dataset, the next thing we need to do is to prepare two sets of vocabularies of Hindi and English. Now, before training the language translation model, we need to set the input and target values. Now, as we have prepared our dataset, let's train a model for the task of language translation model. For this task, I will first split the data and then we will move forward to train our model. Now let's train our language translation model. So we have successfully built and trained our model for the task of language translation with machine learning. Now, let's see how the model performs by translating a sentence. I hope you like this tutorial on language translation model with Python programming language to translate English to Hindi. The coronavirus epidemic has changed the lives of people around the world, but the emergence of its vaccine has led to positive and negative reactions all over the world. In this tutorial, I will introduce you to a data science project on COVID-19 vaccine sentiment analysis using Python. Media messages may not always align with science, as the misinformation, baseless claims, and rumors can spread quickly. This is what we saw with the introduction of the COVID-19 vaccine. In this data science project, we aim to analyze tweets recorded about the COVID-19 vaccine to analyze the sentiments of people for the vaccine. Twitter is a microblogging and social networking platform where users post and interact with messages called tweets. With more than 166 million daily users, Twitter is a valuable data source for any social media discussion related to national and global events. So, the dataset for the sentiment analysis task for the COVID-19 vaccine was collected from Twitter. I will start the task of COVID-19 vaccine sentiment analysis by importing all the necessary Python libraries. In this code, I'll be doing some text pre-processing of the functionality of our dataset, which contains the body of the tweet. Our goal is to perform sentiment analysis on clean text data to avoid noise and reading errors. Whether sentimental analysis relies on a dictionary that maps lexical characteristics to emotional intensities called sentiment scores. A text sentiment score can be obtained by summarizing the intensity of each word in a text. For example, words like love, appreciate, happy, will convey a positive feeling. Also, Vader is smart enough to understand the basic context of such words, such as dislike, as a negative statement. It also includes an emphasis on capital letters and punctuation, such as enjoy. Now let's prepare the data for vendor sentiment analysis. You can observe that the distributions of sentiments follow a normal distribution. Negative and positive feelings are very similar, suggesting that there can be no significant differences in a strength of the positive and negative feelings in our data. It is also clear that the dominant sentiment is natural. Oddly enough, most tweets don't sound more like natural positive or negative feelings. Now let's start with analyzing the cutoff for the most negative sentiments and the most positive sentiments. Now let's visualize the most negative and the most positive sentiments. At last, let's have a look at the top 10 most negative and most positive sentiments. I hope you like this tutorial on a data science project on COVID-19 vaccine analysis with Python. We all plan trips, and the first thing to do when planning a trip is finding a hotel. There are so many websites recommending the best hotel for our trip. In this tutorial, I'm going to walk you through how to build a hotel recommendation system with machine learning in Python. The hotel recommendation system aims to predict which hotel a user is most likely to choose from among all hotels. So to build this type of system, which will help the user to book the best hotel out of all the other hotels. We can do this using customer reviews. For example, suppose you want to go on a business trip, so the hotel recommendation system should show you the hotels that other customers have rated best for business travel. It is therefore also our approach to build a recommendation system based on customer reviews and ratings. In this section, I will take you through a project on a hotel recommendation system with machine learning using Python programming language. The dataset that I'm using here is downloaded from Kaggle, as you're going to build a recommendation system according to the user ratings, so here I will be using natural language processing. Now let's import the necessary Python libraries and a dataset to get started with the task of creating a hotel recommendation system. This dataset contains hotel data from 6 countries, namely 1 Netherlands, 2 United Kingdom, 3 France, 4 Spain, 5 Italy, and 6 Austria. So for simplicity, I will change the name from United Kingdom to UK. I can also see that there is no column as country to specify the destination of the hotel, but in the hotel underscore address column, the last word mentioned is the name of the country. So I will extract the names of the countries from that column and store the name in a new column. Now we will drop the unnecessary columns that we don't need for the task of creating a hotel recommendation system. Now we will create a function to convert the strings of list into a normal list and then apply it to the tags column in a dataset. Now I will lowercase the tags and countries column for simplicity. Now let's define a function to recommend the names of hotels according to the location and a description provided by the user. Here, our aim is not just to recommend the name of the hotel, but also rank it according to the user ratings. Now let's test this function by selecting any country out of the 6 countries mentioned in a dataset and describing the purpose of our trip and see how it works. So we can see interesting results by the recommendation system. I hope you like this tutorial on how to create a recommendation system with machine learning using Python. Email spam, or also called as junk emails, are unsolicited messages sent in bulk by email or spamming. In this project, I will show you how to detect email spam using machine learning technique called natural language processing and Python. So this program will detect if an email is a spam 1 or not 0. First, import the libraries. So load the data and print the first 5 rows. Now let's explore the data and get the number of rows and columns. Get the column names in a dataset. Check the duplicates and remove them. See the number of missing data for each column. Stop words in natural language processing are unless words or data. Now create a function to clean the text and return the tokens. The cleaning of the text can be done by first removing punctuation and then removing the unless words, also known as stop words. Now convert the text into a matrix of token counts. Now we need to split the data into training and testing sets, and then we will use this one row of data for testing to make our prediction later on and test to see if the prediction matches with the actual value. Now we need to create and train the multinomial naive-based classifier, which is suitable for classification with discrete features. See the classifier prediction and actual values on a data set. Now let's see how well our model performed by evaluating the naive-based classifier and the report confusion matrix and accuracy score. It looks like the model used is 99.71% accurate. Let's test the model on a test dataset, X-test and Y-set, by printing the predict value and the actual value to see if the model can accurately classify the email text. Now let's evaluate the model on a test data set. The classifier accurately identified the email message as spam or not spam with 99.2% accuracy on the test data. Data augmentation is a technique in deep learning which helps in adding value to our base dataset by adding the gathered information from various sources to improve the quality of data of an organization. Data augmentation is one of the most important processes that makes the data very much informational. Improving the data is very important for every business because data is considered as the oil of business. Data augmentation can be applied to any form of the dataset, which mainly includes text, image, and audio. Data augmentation helps in a study of the insights based on customers, product sales, and various other departments where the use of additional information can help a business to study the insides of the data very deeply. In this tutorial, I will show you the most used field of data augmentation, that is image augmentation. Here I will show you some manual image augmentation and manipulation using TensorFlow. In deep learning, data augmentation is a very common technique to improve the results and overfitting. To move further in this tutorial, you need to install a package using the pip installer command pip install tensorflow_docs. Now let's import all the libraries we need to this task. Now let's go through all the data augmentation features using an image, and later I will apply those features in a whole dataset to train a deep learning model. The image that I will use in this tutorial can be downloaded in required file in the section. Now let's read the image and have a quick look at it. Now we'll simply read and decode the above image in a format of tensor. Now I will create a function to visualize the comparison between the original image and the augmented image. Let's start with flipping the image. Here I will flip the image either horizontally or vertically. Now let's move further by applying the grayscale features to the image. Now we'll move further with adding the saturation factor to the image. Now we'll move further with changing the brightness level of the image. Now I will rotate the image with 90-degree angle. Now, before applying all the above features on a dataset, let's have a look at one more feature, that is cropping the image. Now I will apply the data augmentation features on a dataset and then use that augmented dataset for training a model. Now I will create a function to augment the image in the dataset, and then I will map the function on a dataset. This will return a dataset that will augment the data on the fly. Now I will create an augmented dataset. Now I will create a non-augmented dataset to draw comparisons. Now I will set up a validation set. Note that the validation set will never change whether you are using augmentation in your model or not. Now I will create and compile a fully connected neural networks model with 2 layers. Now I will first train a model without data augmentation. And now I will train the model with augmentation. So our augmented model produced the accuracy of 95% on a validation set, which is slightly higher than the accuracy of non-augmented model, which is 94%. With respect to the loss, the non-augmented model is overfitting the dataset, whereas the augmented model is fitting and training on a dataset very well. I hope you liked this tutorial on data augmentation in deep learning. In this tutorial, I walk you through how to convert an image to a pencil sketch with Python and less than 20 lines of code. Python is a general-purpose programming language, and with the growing popularity of Python, it can be used in any task today. Before we write any code, let's go over some of the steps that will be used and try to understand them a bit. First, find an image that you want to convert to a pencil sketch with Python. I will be using the image of a nature. Next, we need to read the image in RGB format and then convert it to a grayscale image. This will turn an image into a classic black and white photo. Then the next thing to do is invert the grayscale image, also called negative image. This will be our inverted grayscale image. Inversion can be used to enhance details. Then we can finally create the pencil sketch by mixing the grayscale image with the inverted blurry image. This can be done by dividing the grayscale image by the inverted blurry image. Since images are just arrays, we can easily do this programmatically using the divided function from the CV2 library in Python. Let's go. The only library we need for converting an image into a pencil sketch with Python is an OpenCV library in Python. It can be used by using the pip command pip install opencv-python, but it is not imported by the same name. Let's import it to get started with the task. I will not display the image at every step. If you want to display the image at every step to see the change in the image, then you need to use two commands. Now the next thing to do is to read the image. Now after reading the image, we will create a new image by converting the original image to grayscale. Now the next step is to invert the new grayscale image. Now the next step in the process is to blur the image by using the Gaussian function in OpenCV. Then the final step is to invert the blurred image. Then we can easily convert the image into a pencil sketch. And finally, if you want to have a look at both the original image and the pencil sketch, then you can use the following commands. So this is how we can convert an image into a pencil sketch with Python. I hope you liked this tutorial on how to convert an image into a pencil sketch with Python. The term hate speech is understood as any type of verbal, written, or behavioral communication that attacks or uses derogatory or discriminatory language against a person or group based on what they are, in other words, based on their religion, ethnicity, nationality, race, color, ancestry, sex, or another identity factor. In this tutorial, I will take you through a hate speech detection model with machine learning and Python. Hate speech detection is generally a task of sentiment classification. So for training a model that can classify hate speech from a certain piece of text can be achieved by training it on a data that is generally used to classify sentiments. So for the task of hate speech detection model, I will use the Twitter data. The dataset I will use for the hate speech detection model consists of a test and train set. The training package includes a list of 31,962 tweets, a corresponding ID, and a tag 0 or 1 for each tweet. The particular sentiment we need to detect in this dataset is whether or not the tweet is based on hate speech. So let's get started with the task of building a hate speech detection model. I will simply start with reading the datasets by using the pandas package in Python. Data cleaning is the process of preparing incorrectly formatted data for analysis by deleting or modifying the incorrectly formatted data, which is generally not necessary or useful for data analysis, as it can hinder the process or provide inaccurate results. Now we will perform the process of data cleaning by using the RE library in Python. If you will deeply analyze the task we are working on with context to the data we are using, you will find that the tweets regarding hate speech are comparatively lesser than others, so this is a situation of an unbalanced data. If we will fit this data to train our hate speech detection model, then the model will not generalize any hate speech because the data with context to the hate speech is very less than the positive ones. So in this situation, we need to prepare the data to fit properly in our model. There are a number of methods you can use to deal with this. One approach is to use either oversampling or downsampling. In the case of oversampling, we use a function that repeatedly samples with a replacement from the miniatory class until the class is the same size as the majority. Let's see how we can handle this. For simplicity and reproducibility of the hate speech detection model, I will use the Scikit-learn's pipeline with an SGD classifier before training our model. Now, before training your model, let's split the data into a training set and a test set. Now let's train the model and predict the results on a test set using the F1 score method. So we got an F1 score of 0.96%, which is generally appreciable. This model can now be deployed and used in production. I hope you liked this tutorial on hate speech detection model with machine learning. This tutorial is based on SMS, spam detection classification with machine learning. I will be using the multinomial naive-Bayes implementation. This particular classifier is suitable for classification with discrete features, such as in our case, word counts for text classification. It takes in integer word counts as its input. On the other hand, Gaussian naive-Bayes is better suited for continuous data, as it assumes that the input data has a Gaussian or normal distribution. Let's start by importing the libraries. Read the dataset. Dropping the unwanted columns unnamed 2, unnamed 3, and unnamed 4. Checking the maximum length of SMS. Number of observations in each label, spam and ham. Bag of words approach. What we have here in our dataset is a large collection of text data. Most machine learning algorithms rely on numerical data to be fed into them as input, and email or SMS messages are usually text-heavy. We need a way to represent text data for machine learning algorithm, and the bag of words model helps us to achieve that task. It's a way on extracting features for the text for use in machine learning algorithms. In this approach, we use the tokenized words for each observation and find out the frequency of each token. Using a process which we will go through now, we can convert the collection of documents to a matrix, with each document being a row and each word or token being two columns, and the corresponding row and column values being the frequency of occurrence for each word or token in that document. For example, let's say we have 4 documents as follows. Hello, how are you? When money went from home, call me now, and hello, call you tomorrow. Our objective here is to convert this set of text to a frequency distribution matrix as follows. Here, as we can see, the documents are numbered in the rows, and each word is a column name, with the corresponding value being the frequency of that word in a document. Let's break this down and see how we can do this conversion using a small set of documents. To handle this, we will be using Scikit-learn's count vectorizer method, which does the following. 1. It tokenizes the string, separates the string into individual words, and gives an integer ID to each token. And 2. It counts the occurrence of each of those tokens. Step 1. Convert all strings to their lowercase form. Step 2. Removing all punctuations. Step 3. Tokenization. Step 4. Count frequencies. Here we will look to create a frequency matrix of a smaller documentation set to make sure we understand how the documenter matrix generation happens. We have created a sample document set documents. Documents equal to hello, how are you? Win money, win from home, call me now, hello, call hello you tomorrow. In the above step, we implemented the version of the count vectorizer method from scratch that entailed cleaning our data first. This cleaning involved converting all of our data to lowercase and removing all punctuation marks. Count vectorizer has certain parameters which take care of these steps for us. They are lowercase equal to true. The lowercase parameter has a default value of true, which converts all of our text to its lowercase form. Token pattern equal to question U, B, W plus, and B. The token pattern parameter has a default regular expression value of question U, B, W, W plus B, which ignores all punctuation marks and treats them as delimiters, while accepting alphanumeric strings of length greater than or equal to 2 as individual tokens or words. The stop words parameter, if set to English, will remove all words from our document set that match a list of English stop words, which is defined in Scikit-learn. Considering the size of our dataset and the fact that we are dealing with SMS messages and not larger text sources like email, we will not be setting this parameter value.
I will use Scikit-learn naive Bayes method to make prediction on our dataset for SMS spam detection. Specifically, we will be using the multinomial naive Bayes implementation. This particular classifier is suitable for classification with discrete features. It takes in integer word counts as its input. On the other hand, Gaussian naive Bayes is better suited for continuous data, as it assumes that the input data has a Gaussian or normal distribution. Now that we have made predictions on our test set, our next goal is to evaluate how well our model is doing. There are various mechanisms for doing so, but first let's do a quick recap of them. Accuracy measures how often the classifier makes the correct prediction. It's the ratio of the number of correct predictions to the total number of predictions, or the number of test data points. And precision tells us what proportion of messages we classified as a spam actually were spam. It's a ratio of true positives to all positives. In other words, it is the ratio of true positives divided in tuple true positives plus false positives. And recall or sensitivity tells us what proportion of messages that actually were spam were classified by us as spam. It's a ratio of true positives to all the words that were actually spam. In other words, it is the ratio of true positives divided in tuple true positives plus false negatives. Companies often receive thousands of resumes for each job posting and employ dedicated screening officers to screen classified candidates. In this tutorial, I will introduce you a machine learning project on resume screening with Python programming language. What is resume screening? Hiring the right talent is a challenge for all businesses. This challenge is magnified by the high value of applicants if the business is labor-intensive, growing, and facing high attrition rates. An example of such a business is that IT departments are short of growing markets. In a typical service organization, professionals with a variety of technical skills and business domain expertise are hired and assigned to projects to resolve customer issues. This task of selecting the best talent among many others is known as resume screening. Typically, large companies do not have enough time to open each CV, so they use machine learning algorithms for their resume screening task. In this section, I will take you through a machine learning project on resume screening with Python programming language. I will start this task by importing the necessary Python libraries and the dataset. Now let's have a quick look at the categories of resumes present in a dataset. Now let's have a look at the distinct categories of resume and the number of records belonging to each category. Now let's visualize the number of categories in the dataset. Now let's visualize the distribution of categories. Now we'll create a helper function to remove the URLs, hashtags, mentions, special letters, and punctuations. Now, as we have cleared the dataset, the next task is to have a look at the word cloud. A word cloud represents the most numbers of words larger and vice versa. Now I will convert these words into categorical values. Now the next step in the process is to train a model for the task of resume screening. Here I will use the 1vs the res classifier, co-neighbors classifier. For this task, I will first split the data into training and test sets.
Now let's train the model and print the classification report. So this is how we can train a machine learning model for the task of resume screening. I hope you like this tutorial on resume screening with Python programming language. In this tutorial, I will create a model for credit card fraud detection using machine learning predictive model autoencoder and Python. Let's start with importing libraries. The dataset I'm going to use contains data about credit card transactions that occurred during a period of 2 days with 492 frauds out of 284,807 transactions. All variables in the dataset are numerical. The data has been transformed using PCA transformation due to privacy reasons. The two features that haven't been changed are time and amount. Time contains the seconds elapsed between each transaction and the first transaction in the dataset. Read the dataset. Checking the shape of data. Checking for null values. There are no null values in a dataset. Checking number of records of each kind of transaction class, fraud and non-fraud. The dataset is highly imbalanced, looking at each of the fraud 1 and non-fraud 0 transactions. Since only 3 of the features, time, amount, and class, are non-anonymized, let's explore them. Graphical representation of amounts.
plotting time of transaction to check for correlations. The time doesn't seem to be a crucial feature in distinguishing normal versus fraud cases, hence I will drop it. The numerical amounts in fraud and normal cases differ highly, hence we scale them, scaling the amount using standard scaler. We will be using autoencoders for the fraud detection model. Using autoencoders, we train the database only to learn the representation of the non-fraudulent transactions. The reason behind applying this method is to let the model learn the best representation of non-fraudulent cases so that it automatically distinguishes the other case from it. Splitting the data into 80% training and 20% testing. Autoencoder model. Training the credit card fraud detection model. Scaling the values. Obtain the hidden representation. Model prediction. getting the representation data, train, test, and split. Credit card fraud detection prediction model. YouTube is the world's most popular and widely used video platform today. In this tutorial, I'm going to introduce you to a data science project on YouTube trending videos analysis with Python programming language. The dataset that I will be using for the analysis of YouTube training videos was collected over 205 days. For each of those days, the dataset contains data on trending videos for that day. It contains data on over 40,000 trending videos. We will analyze the data to get insight on trending YouTube videos to see what is common among all trending videos. This information can also be used by people who want to increase the popularity of their videos on YouTube. Now let's get started with the task of YouTube training videos analysis with Python by importing the necessary libraries. Now let's read the data and set a few configuration options just to improve visualization plots. The description column has some null values. These are some of the rows with null description values. So to do some sort of data cleaning and to get rid of these null values, I'm going to put an empty string in place of each null value in the description column. Now let's take a look at some statistical information about the numeric columns in our dataset. Observations from the above table. Now we want to see how many training video titles have at least one uppercase word. To do this, we will add a new variable to the dataset whose value is true if the video title contains at least one upper word and false otherwise. Let's add another column to our dataset to analyze the length of titles of videos, then plot the title length histogram to get an idea of the length of trending video titles. We can see that the video's title length distribution looks like a normal distribution, where most videos have a title length of around 30 till 60 characters. Now let's draw a scatter plot to analyze the relationship between the title length and the number of views. Now let's see how the variables in a dataset correlate to each other. For example, we would like to see how views and likes correlate, meaning that views and likes increase and decrease together. The correlation map and correlation table above indicate that views and likes are strongly positively correlated. Let's see if some words are used meaningfully in trending video titles. Let's draw a word cloud for the titles. Let's draw a word cloud for the titles of our trending videos, which is a way to visualize the most common words in the titles. The more common the word, the larger its font size.
I hope you like this tutorial on data science project and YouTube training video analysis with Python.